So, good morning, everyone. I'm so thrilled to be here. You know, I'm on Twitter and I always see these conferences from the US and I see them pass by and they're so far away and it's a bit expensive to get there and it takes a lot of time. So I was incredibly thrilled when I saw there was an Amsterdam session. I live in Flanders. It's only a 2 hours drive, so of course I kind of had to be here. Surprise, surprise, my talk is going to be about DPLYR. Bet you didn't guess that one. It's not going to be a base DPLYR version. I am going to assume that most of you know DPLYR. Is there anyone who doesn't know DPLYR at all? Good, because otherwise, and if you're too shy to say now, you might get lost a little bit. But then once you learn DPLYR, just come back to this and hopefully that will help you. So a little bit about me. I'm a biochemical engineer. I don't do anything biochemistry anymore. After I graduated, I joined Procter & Gamble for their research and development organization, where I was until yesterday. So yesterday was my last official day. I handed in my laptop and the whole thing. And on Monday, I'm starting making data not just a large part of my job, but the part of my job as a business intelligence and analytics consultant for Gedera. So this is a weird weekend. I'm on a 2 days unemployment schedule here. There is only one big impact, which is I also don't have a hospitalization insurance for 2 days. So please don't stop me today or tomorrow, because then, you know, I'm going to be broke on Mondays. Well, preferably not. Anyway. So being in R&D, we do a lot of data analysis, we get a lot of data, but as is quite common in big private companies, we have some R users and we have some Python users, but the company tools are graphic user interface. And so that's how I started as well. My data analysis journey started with SPSS, and then I moved a couple of years ago, I think for 7 years, to JUMP, which is a SAS program, but it's also graphical user interface. And I made the decision for myself to just move to R. And it was, for a large part, you know, steep learning curve. And of course, I cursed and Googled and Stack Overflowed a lot. But overall, I was very pleased for all the reasons that I'm sure you know. So I'm not going to talk about the advantages. However, there are 2 data sets that I have at work that were such a pain in the ass. And every time I would have to do something, I would go like, I'm going to do it in R. And then after 5 minutes, I closed R, opened JUMP, and 5 minutes later, I had the analysis. And part of why I didn't persist at work is, you know, I made a decision to go to R, not my employer, so it felt a bit bad to do something that I could do in 5 minutes and take 2 days. So I would not do it, and then at home, I would be so incredibly frustrated and just try stuff out. And I call it my multi-column challenge. But I will get back to that after a little while. I'm just going to talk a little bit about the basics of DPLYR first. So DPLYR, I have nothing to do with DPLYR. My contributions are limited to 1 pull request on documentation 3 weeks ago, and that's it. It is a package that most of you will know. It's part of the Tidyverse. Our studio folks are the ones maintaining it. These are the official people listed on CRAN. I'm sure there are a lot more people who contribute. Some of them are here. We just heard, and Romain, I thought I saw him somewhere. So I am not the DPLYR expert, but I'm a user, and I discovered something useful that is not very well known, and so I'm trying to share it. The last part of my talk is going to have a lot of code, so obviously I need a data set to work with. And my data set is a complete crime scene. I did a lot of survey before. I designed surveys and I analyzed them. I made this very short survey just to have a data set to work with. It is an abolishment, so it's not serious. Please don't act like it is. I definitely won't. And the second thing is I just put this survey on Twitter, so I have a huge selection bias because the only people that are in my data are people who follow me on Twitter or follow someone who follows me. So, of course, not even remotely representative for the R community. It's just some fun to work with. One of the first questions that I asked was a very open-ended question because I wanted to know, this is not factual, what did people use, what packages do people use every month? You'd have to scrape their actual scripts to know. I just wanted to know, like, which packages do they think they use an awful lot? And so they listed top of mind all the ones they could think about. And this was no surprise to me. There's a top 3 that is well ahead of everything else. Again, not representative for the whole R community. I do want to mention that. But it's no surprise because ggplot2 and DPLYR and then Tidyverse that encompasses everything are all-purpose packages. Whether you are coming to R and you're going to do a script to clean your data or to do some predictive modeling or to do something completely different, you are going to need to wrangle data. There's usually no way out, and most likely you're going to plot as well. So this is a very important package. But the other thing that I wanted to know is how many functions do people know about DPLYR? So I asked, top of mind, which are all the ones that you can think of. And so some people answered 3 and some people answered 33, which is still only about a third or a fourth of the actual ones in there. But again, this was not a huge surprise. Most people use DPLYR, and I kind of going to hear the golden 6. By doing so, I also realized that the standard gold color in R kind of really sucks. But this is officially gold. So the filter, mutate, select, summarize, group by, and arrange are the ones that most people know. Then there's quite a gap. Then there are a couple of the joins that are absolutely amazing. Every time I have to do SQL, I hate that I don't have an anti-join in SQL. Those are the ones everyone knows about. I'm not going to talk about those. I'm going to talk about some of the variants that are a lot less known. Now, there are a few in here. So there are people who know about the mutate at and the mutate if and the summarize all, and they're so incredibly useful. So I'll talk an awful lot more about those functions. Just to have a data set to work with, I asked 3 other questions. It's not actually that important. I just needed columns to fill. So I've taken 15 packages from CRAN, and I asked people, how frequently do you load these? Actively, not dependencies. I wanted agreement questions as well, so I took 7 quotes and asked people whether they agreed and to what extent. And then lastly, because every survey needs to have some demographics, I put in some demographics. But those are not hugely useful. But now you know what data you're going to see all the time. Back to my multi-column challenge. I'm going to share 2 examples. So I put, like, the cat was looking very weirdly at 2 data sets. And one of them is like a prototype overview. So I worked until yesterday in a research and development for Procter & Gamble. We make cleaners and shampoos and all of those things. So something that looks like this is quite common. I know you can't completely read it at the back, but I will take you through it. We have this big Excel file. And we have prototypes and a lot of information about prototypes, which are the green columns, like my colleagues who actually design them. They tell me what they put in and at what level. And then, of course, we test all our prototypes, so there are a lot of test methods. And one of these typical features is you never have one data point, depending on the temperature. So I have a measure 1 and a measure 2 here that are temperature-based, so we run it at different temperatures. We have other measures that are temperature and time-based. And then we have measures that have absolutely nothing to do, that are concentration or something completely different. So this is small. The data sets I normally have, they're usually not very long. I might only have 20 observations, but I might have 150 columns. And when you're still fairly new to R, it's not that funny. You read up on all the blogs and tutorials, and they all say the same thing, and they say, just make your wide data set, make it long. This is what you get. And this is only 2 prototypes. Because, the standard examples are usually quite simple because they have 1 dimension and 1 measure, or 1 dimension and 3 measures, but I have a lot of dimensions here, and some measure just have 1 of them. So I have all my prototype information, then temperature, time, and concentration were dimensions, and I have my 4 measures, M1, M2, M3, and M4. But I don't get very happy from data sets like this. I have a lot of duplication, I have a lot of not availables, and if I kind of just want to go in and look at one thing, I much prefer it in the wide one. The second one with surveys, this is actually an Excel screenshot of what the output from the Google Forms, the survey I just talked about, would look like. It's a similar thing. 1 person is 1 line, and then I asked about 15 packages on the frequency people loaded them. So now I get 15 variables with I always load it or I never load it. I asked 7 quotes, and I asked how much people agreed with it, and I get 7 variables with agreements. If you try to make this whole thing from wide to long, it's almost impossible, and if you try, you're going to end up with a big mess. And really, really, all I wanted to do was I wanted to clean up all the variable names, because I'll show you in a second, it's a mess. I want to record all of those observations, and I want to summarize the variables. It shouldn't be that hard. So what are my options? So remember, I was a beginner in R. I was using R 1 or 2 months. And so I'm thinking, okay, I could go manual. I could do column by column. So for my 7 quotes, it means 7 renames, 7 mutates, 7 summarizes. That's doable, but then you get 15 of something else columns and 20 of something else, and of course it becomes absolutely horrendous. Not really a good option. The second one is, at school I had a lot of coding in Java and even before that in Turbo Pascal. So whenever I hear do something over and over again, you think about loops and iterations. So, you know, write a function, pour your way through it, or even do a for loop if you want to. But that gets quite complicated quite fast as well. And if you're beginning out, you get so cast in all the issues. No, I mean, close R, go back to jump, you know, open window, pour all of them in, press run, and it's done. So not really a good option. The third one, and before I talk about this one, I do want to stress that this is a completely valid and okay approach. And I know a lot of people who do it, which is don't take the whole data set. If I want to analyze those 7 quote variables, just grab the 7 quote variables, make those long, mutate, group by, summarize, and you've got it. And this is, a lot of people are very happy with this approach. I'm not. And the reason I'm not, and again, it's not if this is what you do, I know a lot of people who do it, there's absolutely nothing wrong with this approach. The reason that I don't like it is I have to do a lot of these analyses. I have to do a lot of breakouts. I also end up with all kinds of different long data sets that do belong to one, and maybe you want to look at all the people who liked a certain quote and which packages they load. And so you end up in such a mess of different data sets. So I really want to keep it wide for as long as is possible. So again, you know, close R, go back to jump. And then one day I had the very interesting experience for an Our Ladies workshop in Brussels. Environment. I printed all of the DPLYR documentation and I went through it. And there were a lot of functions where I was not quite sure what to do with this. And then there were a couple that were super interesting and I thought, okay, this could be so much shorter. But the ones that really kind of changed my R life are the scoped DPLYR functions. And those are the ones that we're going to be talking about today. And so my entire challenge before of me writing to make these huge functions or gathering into very small data sets and working with that all of a sudden became very easy. I'm not going to explain the code now. There's going to be plenty of examples later. But all I have to do now is I start from these very, very wide data sets. I select all the ones that are called quotes. I immediately completely change the variable name to something that is useful. I mutate, I immediately change all of the observations, and at the very end, I just say, summarize all. And I'm getting, well, and then because then you get a weird variable thing. I do like to gather, just not front. I get it in a nice table, and then it becomes so easy. I get all my columns, it's analyzed, and if anyone is curious, the quote that most people agreed with is a quote by Joe Abercrombie. I don't know whether you know Joe Abercrombie. He's a fantasy author. I absolutely love him. And in Best Served Cold, he said, you should love every moment you live, or you'll find it decidedly difficult afterwards. Well, that's kind of true. But that's not the point. The point is, when I saw this and just being able to clean up those 7 variables or 15 or 30 and not having to group them and gather them up front, it was really like, hooray, I finally arrived. To me, that's the moment I actually never went back to jump, only when I was in very close collaboration with someone else and everyone else was still using jump. I still did, but for myself, as of then, I just did everything in R. So they're called the scoped DPLYR functions. And what they do is you have your normal verbs, so the ones that most people know, filter, select, arrange, mutate, transmute, rename, forgetting 2 here. They'll work on like 1 column, but there are versions of that same word that work on multiple columns. So DPLYR all doesn't exist as a function. You have to put another function name into the DPLYR thing here. But you have select all, and then you're selecting all your variables. Why that would be useful, I'll show you later. Or mutate all, and you can immediately change all of your observations to something. You don't always want to do everything on all your variables. So there are two other versions. There is DPLYR if, so summarize if, mutate if, and so on, when you want to do something to a set of variables and you can define them by their characteristics. So if the variables that you need, they're all numeric, you can say, well, take all the numeric columns and do this to it. And if there's no common characteristic, there is a third version, which is to take a set of variables to do something to, and they share something in their name that is quite common, and then you select them that way. If you're a bit lost now, don't worry. We're going to go to a lot of code now. So I'm just going to swap. You're not seeing this yet. And there you go. These are slides that, because there's so much code in it, I made them all in Schwingen. I don't know how to pronounce that, I'm sorry. I'm new to Schwingen, so I didn't put my whole presentation in there yet. Otherwise, this would have been a week of learning that package instead of making a talk. So that's why it was in 2 steps. There's a lot of these slides, so I hope in the back they're readable, because it has the code and immediately always the run-through. So I hope that's going to be manageable. My data sets. I have my survey, and just to show you now in R what that looks like when you get the download from just about every survey software I know. They're very kind because they put the whole question that people got as a variable name. So some of these variable names are actually 3-4 sentences. So it looks completely rubbish. I get a timestamp. This was my opening, like which packages do you know. Then I have 15 columns on the frequency of loading a certain package. And I have page 2. 1 on the DPLYR, then 7 quote variables, and then some of my demographics. And this is a very, very short survey. Like normally I would have 200, 300, 400 columns like this. Now to make it manageable on screen, I don't always want to show you 2 screens, so I made a subset for most of the examples right now that just contain 12 variables, and then it kind of fits on there. So the first thing I want to do is this. Yeah, that's a mess. So I want to change the variable names. And just a very quick refresher on select, which is what you can use to rename variable names. The select function selects variables, so I can take my data frame and I can say select which generation do you belong to, and select which month do you celebrate your birthday, and I'm going to keep just those 2 columns. Now, one of the nifty things is you can immediately rename within select. So I could do exactly the same, but I'm saying select the generation thing, but call it generation, and select the month thing and call it month born. I'm keeping my 2 variables, but I've renamed them. The difference between, there also is a rename function in DPLYR. The difference between the 2 is when I do select, generation is something else. I'm just keeping the ones I talked about. If I would do rename, I would keep all my variables and just rename 2 of them. So it depends on whether you keep all of them or whether you just want the set that you can use the 2. That's the normal select function. So I'm going to start with select all. I'm going to talk through select all, select if, and select add quite at length just to explain everything. But the good thing is the syntax is so incredibly consistent that if you know how the select ones work, you know how the mutate works and the summarize and everything else. So if you're wondering why I'm spending so long on this one, it's just because everything else is kind of the same. So why would you ever select all columns? Because if you don't do a select statement, you already got them all, so it seems a bit silly. But one of the things that you can do within select is rename everything immediately. And so the syntax would look like this. You would have select all your data, which if you're using a pipe will be piped through, so you don't have to worry about that one. And then you're going to give the function, you're going to give select all a function, which is going to use to change all the variable names. Example, I have my data and I'm saying select all to lower. And what is going to happen? Very simple. He's going to take all my variable names and he's going to return all lower cases. So in the past, timestamp was with a capital T. The I've said, everything has gone to lowercase. Now, importantly, the observations itself, so this is a call without the glimpse statement, so I'm getting some of the actual observations. The observations have not changed. The only thing that changed are the variable names. The capital I went to a small one, but here I've got everything left. That's because it's a select statement. Select is not going to change your observations. Sounds good. One of the things I'm seeing as well in my variable names is I have a lot of white spaces. We don't really like white spaces, so let's do the same thing. Select all, string replace all the white spaces with an underscore, and we get an error. Firstly, maybe a quick word about the dot. I don't know whether everyone knows what a dot is, because that's a question I sometimes get. I can't give you the very technical explanation, but in my head, the dot is the thing you're looking at, and usually that's correct. So the thing I'm looking at here are all my variable names, and he's going to look through all the variable names, look at every white space, and replace it with an underscore. But we're getting an error. It looks the same, though, as above. There's one very critical difference, is when we look at to lower, it is just the function name. We didn't use brackets. With string replace, I opened the brackets because I had to put in the arguments of what to take and what to replace it with. And the moment you do that, you're not just calling the function by name, you're kind of letting it run already, which is why it thinks it's got 12 things instead of 1, because I have 12 variable names. So the way to fix this is pretty simple. And if you use the per package, you already know this. You just put a tilde in front. And the tilde is telling R, take that thing and turn it back into a function. There is an alternative, which is to wrap it into funds. And in most of the documentation, this is what you will find, but the tilde works as well. So it's the same thing. You take your string replace all, and you wrap it either in funds or you put a tilde in front. And so now what you can see is we don't get an error anymore, and every single white space that I had is gone, and it's replaced with an underscore. Now, this is still a mess. These are two very easy examples, but my variable name, even this one, is not one I would actually like. So you can regex your way completely through this. And so this is just one example. I'm not going to share the whole thing, but just the principle. This is very similar, only I'm not just replacing a white space with an underscore. I'm taking something, a set of words, that is valid for only the columns that I want to touch. I made it a bit longer than I would usually do, just to make sure everyone's following. So I'm asking him, go through all the columns. If you see the phrasing something, set of frequently something with a square, replace that whole thing by frequently load package. And so what I'm getting now is not anymore these 3 gigantically long sentences. I'm just getting frequently load package, which I told him to, and I'm leaving the packages here at the end. I still have an error there, but that's fine. That will disappear lately. So I will go through every single one of my variables names like this. It looks like that. I made it a bit longer than is needed, but honestly, it works fine. And at the end of this, I have made all my variable names into this. This is something that's useful in R. The previous one, there's a good thing RStudio has an autocorrect, because otherwise I would die trying to even type the full sentence. But this works perfectly fine. I have very clean variable names now. Remember, this is 11 variables. My real one is 30. My real ones that I would actually use for work or would have used until yesterday might have gotten even more variables. So doing it this way is actually a savior of time, even if it might not look like that on these 11 variables. So that's the all statement. Now, very often you don't want to do something to all your variables. You want to recode some of them, not every single one of them. And so there are 2 other versions. The first one are all the if versions. And the good thing is the syntax is extremely similar. So select if, I have my data. In many cases, that will be piped through, so you don't have to actually type that anymore. I have my function that I want to use to rename with at the end. It works exactly the same way as with select all. The only thing that is different is I need to tell him what to look for. Select if what. So we're going to need to put that in. Something else first before we're modifying anything. Select if in itself is already pretty useful, even if you don't want to change any variable names, because it can be a lot shorter. If you're doing an analysis and, I don't know, you have a data set with a lot of numbers and just some characters that describe it and you want to do something with it, it can be very short to just write data frame, select if is numeric, and you're going to get all your numeric columns and everything else is out. So even without trying to do anything else, this works, and it's actually pretty useful. If you want to change those variables, so here select if is numeric. I only had one numeric variable, so that's the only one that will be shown. So I'm going to use something else now. If I want to do this, it works the same way. In select all, I would have said select all to upper, and I would have gotten uppercase variable names. In this case, I'm going to say select if it's character, then go and make everything in uppercase. What I'm left with are my 5 character columns, because I used select, and they all have uppercase. If you wanted to leave all of them, and you just wanted to turn some of them uppercase, you would use rename if, and then you keep everything, you just rename part of it. As I mentioned, the function part works exactly the same way as in select all. So if I want to string remove, I have to open the brackets because I have to tell it what to remove. It's not a function anymore. Just put the tilde in front of it. It's a function again. And what it did here is, I'm not going to talk a lot of, I mean, Rita has a talk about regex, so if you're not following completely with some of these symbols, she will make that clear for you. So select if something is a factor, I want you to remove everything that comes until the last underscore. And so after the last underscore, I just had my package names and the person who gave a quote, and everything else is gone. So sometimes that can be useful to clean up for a summary table where you don't want to show the whole variable name. What is useful is, so in this select if, it's always based on characteristics of your columns. So the built-in ones that are super useful, that you don't really have to think about too much, is character, is factor, is ordered, exists, is numeric, is integer, is double, is logical. If you use dates a lot, you can use lubridate, and there is a isdate and is posixt. If anyone knows how to pronounce that correctly, let me know. I always kind of make it up, posixt. Those will work. I also have this thing, if I don't know how to pronounce something, I do it following the Dutch pronunciation rules, which sometimes also is very funny. Those are all built in, so those you can just use and you don't have to do anything else. If you have some very special cases, I didn't load all the examples here because I had way too much material and I had to get down. But you can make your own. You could say, you know, select all the variables where the average is higher than 5, or where I have 4 different answers and not more than that. So all of that works as well, but honestly, the easiest ones are the built-in ones. In some cases, you don't have a common characteristic for what you want to select. You have 5 random variables that you want to keep and you want to do something with, and one is a factor and one is numeric, and 2 are something completely else, and there's a date variable. So there's another way that they smartly build into these functions, which is the add version. The add version, again, the syntax is so incredibly similar that it doesn't, most of this doesn't give a lot of information, doesn't need a lot of explanation, sorry. Select add, again, your data will be piped in if you use it in a pipe. The function works exactly the same way. The only thing that is slightly different is the vars in the middle. And what you have to do with vars is, what you have to do with the add versions of all these functions, if you have to tell it which columns by name that you want to use. So the easiest example is I actually just tell him which columns to use. So I have my data frame, select add, and then between vars, I tell him, do this to continent, generation, and month born. And he's going to give uppercase to those 3. Again, if you wanted to keep all your variables, just use rename add, and everything else will be the same. That works. That is still a lot of type work. And if you have to do it once, it's fine. But if you're going to do this over and over again, it's good to have some shortcuts. The good thing about the vars argument is anything that works within a normal select statement will work within vars. So some of you will know about the select helpers. These are the most known ones, I think, is you can use starts with, ends with, and contains. So if all the variables you want to change start with frequency, you just say starts with frequency. If they all end on something, same thing, or if it's somewhere in the middle, or you're just too lazy to type starts with, you can just say contains frequency, and you're selecting all those. So you don't have to go and type the 15 load frequency package, that kind of thing. Sometimes you're slightly less lucky. I've seen this a lot with like open data, governmental data. They love to put these really complicated variable names in there. And I was doing something on names that are given to people that are born. There is this first name, a Dutch first name that's called Joke, which is spelled G-O-K-E. So, you know, with English becoming so predominant, I wondered how many people still dare to call their name Joke, which would read like joke to anyone who's not Dutch. So I went to all the websites and I got all the names and things like that. And so I noticed like the government, they put these crazy variable names. But you could regex your way into them. And so there is another version. If you can't actually use a set of letters that will describe all your columns, but there is a trend, there is something that is always coming back. You can use matches and put any regex inside that as well. And if you're really unlucky and there is no regexing unless you spend 24 hours trying to solve the puzzle of how you could exactly identify them, there is another way. And this is especially if you're going to do something to select a set of columns and you're only going to do it once, it's not worth it. Just use the column names. But if this is a set of columns that you're going to use quite a bit, it might make sense to pre-identify them. And I'm going to show an example of them. And then afterwards, you can use one-off, which is I think the older way, because I re-downloaded the PDF package, the whole documentation of DPLYR 2 weeks ago, and I can't recall having seen that before, which is the bang bang option, just even shorter. So how does that one work? If I have demographics in my survey, I very often will do a breakout by demographic, or I will look at the demographics. And so what I can do is just once upfront in my script, I'm going to say, you know, my demographic columns are years are experience, continent, generation, and month born. And then afterwards, what I can do is I have my data frame, and I'm going to say select, bang, bang, demographics. And it's going to turn me the demographics. Now, I can hear some of you think, but what if you have a column that's called demographics? Well, that's why the bang, bang is there. Technically, with this data set, if I would just run, I find it's a bit odd, but it's kind of cool. If I would just run this without the bang, bang, it would also work. I would say select demographics. There isn't a column that's called demographics, so he's just going to take that vector from before. But that's where you can run into issues, because if you have a column that's called demographics, so I made one, just, you know, make me a new column that's called demographics, give it a 1. If I would now not do the bang bang, obviously he would grab me the demographics column. So to be safe, just always put the bang bang. I put the bang bang. There is a column named demographics, but it knows not to look within the data frame itself, so it's going to look outside and it's going to return this. This works within a normal select as well. So if you're now thinking, like, I always need these same columns, well, this could save you quite a bit of time. Any of these select helpers will also work within the vars argument. So I'm just going to give one example because it's the same thing. It's so consistent that I don't have to spend a lot of time explaining this. So I have my data frame, select add vars, anything that contains frequency. So he's immediately going to give me those 15 columns, and I'm going to give it a function on how to change the name. So I'm changing the names of 15 columns in one line of code, which I still find actually really cool. Those are the select ones. As I mentioned, they're so similar that I can run so quickly through the next one. First, one other thing, forgot about this. I'm doing some extra data wrangling. This is funny because when I did the survey, there were a whole lot of people who thought that gather, spread, and separate were also DPLYR functions. And I've had that issue as well, that I'm like, you know, please spread this, and then it tells me, like, I don't know what the function spread is. So those are tidyr functions and not DPLYR. What I've done here, just to get some extra messy data, I had this one question where I asked people, like, tell me all the packages that you used in the last month, and they gave it to me in a long string. So I had the first person would have said DPLYR, comma, read Excel, comma, JSON Lite, comma, tidyr. So I split them into all separate columns. But now what I'm getting is I have all these white spaces up front. I have some people who type tidyverse with a small t, others with a capital T. So, I want to change all of those columns again in one go. And I think there are about 15 of those again. So I don't want to do that column by column. Well, just like with select, we have a mutate all, we have a mutate if, we have a mutate at. The syntax is exactly the same. Mutate all, your data will be piped in. You give it a function on how to change your observations. Mutate if, you tell it what condition. So if it's numeric, if it's character, and the function. Mutate at, you give it a set of columns it has to work on, a function, and it's done. So the very easy examples, take my data set, mutate all string trim, and put everything to lower, and with just 2 very, very short line of codes, I got rid of all my empty spaces, and everything is lowercase. So again, this is so incredibly easy. I like it. Something a little bit more complicated. I had a whole set of slides on cool functions with discrete columns like case when and recode factor, but I all had to cut them because, well, I had way too much material. But this works the same way, and if you already, if else I think is one of the easiest ones. Mutate at, take all the, so within vars, take all the columns that start with quote, and then I want you to replace them. If the answer is I strongly agree or I slightly agree, replace it with a 1, otherwise a 0. And I put a tilde in front of it to make sure that it's a column and it doesn't actually execute anything. And so I'm getting my 7 columns in 1s and 0s very easily. Another one, again, completely the same thing. You have summarize all, summarize if, summarize at. The syntax is exactly the same, so the only thing you have to change is the part up front. I have all my recoded, so I recoded everything in 1s and 0s. The first part is exactly the same as we had before. And now the only thing I have to do is summarize at everything that contains quote, give it a mean, and I'm getting all my means. So super short and super easy, if you know it exists. One handy thing, and this is also why I gathered it so you could see my variable name really well, is the standard thing that your mutate and your summarize function will do is it will just rewrite over the variable name. So what I mean is, if you do a normal mutate statement, you can either mutate in your same column, like with empty cars, you'd say cylinder equals something that you want to change cylinder into. So you might want to correct the one that is apparently wrong. And with summarize, the same thing, like you could just do summarize mean, but very often you're giving it a variable name, like call my mean this way. And you might have noticed before, and you can see it here, the standard operating of the summarize all at if and the mutate ones is to take the variable name I had before. So I have quote Yoda and quote Evelyn Waugh and Mark Twain, but luckily I still have mean here, but imagine it was still columns. I wouldn't know what that measure would be. Is it a mean? Is it something weighted? I mean, I have no clue. So one of the things that you can do is you can force him to tag every single name after you've done it. The only thing then is it doesn't work with the tilde. You do have to use, well, unless there is a trick that I don't know, but I tried, you have to use the funds function then. So this is my function means. I'm going to wrap it in funcs, and I'm going to tell him to tag everything with proportion agree. So now I'm not getting quote Yoda, I'm getting quote Yoda proportion agree. So if you're mutating something and you're recoding from, I don't know, in my case it could be from the general agreements to people who agree or disagree, I can change that name very easily as well so people still know what is what. But you do have to use the funds function if you want to do that. Group by has the same kind of functions. To be honest, I know they exist, and every time I think they're kind of cool, but I don't think I've ever really used them. But just so you know, there are group by all, group by if, and group by at ones as well. So here there is one example. I am defining 2 column names into a variable called breakout, and then I can say group by at the variables that are called breakouts with the bang bang, just to make sure that there is no confusion about what to use. And then I'm getting my averages, and he's grouped them by both of those. It exists. I've Personally, I don't think I've ever used it, but, you know, could be useful. The code I've shown before works for nearly all the functions. It works for select, rename, mutate, transmute, summarize, arrange, and group by. The only one that is slightly different is filter, and of course that makes sense because with filter you're not changing anything. You're trying to filter out observations. I don't want to make them uppercase or take some strings out. I want to do something else. And so this is the only one where the code is slightly different, even though honestly it's minor. Two very quick examples to explain that. You have two options. So you want to filter over a lot of columns, and typically there are two things that you want to do. Either you want to keep the observations that have something that is true for all of the columns, or you want to search whether this is present in any of the columns. So on my packages, I want to find the people, like people randomly wrote the package names. I didn't ask them to do it alphabetically, or it wasn't like, do you load this one, yes or no? So if I want to find everyone who uses JSON-Lite, which is one of my very frequently used packages, I could go by every single column, or I can just say, filter all of my columns and look for the word JSON-Lite. And if it's in any of the columns, I want you to retain that row and otherwise get rid of it. So there were only 3 people in the 126 completely biased set of our community that used JSON-Lite. If you want to do the opposite, if you might want to filter, add a specific set of columns and you want something to be true for all of them, like if you wanted, if you think about the iris data set, if I really wanted something that has exactly the same petal width as length, that doesn't make sense, but just as an example, you wouldn't use any vars, you would use all vars. So again, it's, if you just read it, it already makes sense, right? Obviously, I had no one who just wrote 15 times, I use JSON-Lite, I use JSON-Lite, I use JSON-Lite, so I have no one. But that's the only difference. All of the other functions work exactly the same way. So you pick one of the DPLYR verbs that you all really know, you put all after it, and it works on all the variables. You put if, it works on some based on their characteristics. And if you put add, you kind of have to tell via vars which ones to use. The only one that is slightly different is filter, where you have to say, I want it to be true on any of the vars, or I want it to be true on all of them. And then I have a whole set of miscellaneous functions, but I have no time. So. Wait, I was telling this yesterday. I'm someone who stays in ID generation a very long time, and I've made all of these examples, and like with all of the tricks that I love so much, NA, if, near, everything, row-wise, add count, and I did a run-through, and I had 2 hours of talk. So I had to completely go back to the scope. But I promised some people I will make all of those things appear one way or another. Just a couple of resources. One, if you're up for a challenge, but I can tell you, you can learn so much from it. Read the documentation, like the full PDF. It is, I do it with a lot of packages now, and it's very interesting. The only one that I haven't wanted to do it, one is the XML package, because it has like 1,000 functions or something. Once I discovered all of these, of course, at first I thought everyone knows these exist, and I'm the only one who didn't know. But I thought of this advice that people give, like you should blog about something that you wanted to know a month ago. So I blogged about these, and I'm still amazed at how much reaction I get, which is also why I'm here today. So a lot of what I shared today, and even more, is in those blog posts. So there's 4 of them. And as of tomorrow evening somewhere, all of this material will be online as well. And that's it.
Thanks a lot.